Safety in working with electricity is of the utmost importance. Don't die when you're working with electricity. Test with the electricity off whenever possible. And verify that it's off either using a plug-in tester like this or one of these stick testers that says voltage is present. Now remember, if you're using this, the small prong is line, the big one is neutral. Neutral does not carry electricity, so don't be fooled. This is the one, the small prong, is where the power comes in. Or you can take a lamp that you know is working and plug it in, and that'll tell you whether or not you have electricity. If you are working with electricity while it's on, which sometimes you have to do, wear insulated gloves, wear shoes. Bare feet will kill you. Don't let your body come in contact with the ground or metal, which might ground you. Stay safe. Don't die.
Hey students, Pappy here, Rich, and today we're going to do a little advanced work. We have a dryer that won't heat, Toasty, our training dryer, and we're going to figure out what's wrong with it using just the schematic diagram. Well, today Mr. Huglewatts called and said, hey, my dryer's not working. It won't heat. So that's the problem we're dealing with. So let's get on over and take a look. Here's Toasty, Mr. Huglewatts' dryer. So we go over to it. We see that it's plugged in. We set the timer for 50 minutes. And then we push the start button to see what happens. Nothing. What's going on? Sometimes when you start out, you got to look at the simple things. And in this case, because the drum light is on, we know the dryer door is not closed. And the dryer won't run without the door closed. So we're going to close the door, and then we try again. I don't know if you heard that, but the motor started up. There it is. And the next thing would happen would be the burner assembly would go into his gas lighting process, which starts with this igniter heating up, and I don't see it heating up. So let's go from there. We're going to use the schematic diagram to see what's wrong with Toasty. Remember, this diagram on the top is for an electric heat dryer, and the diagram at the bottom is for a gas heat dryer. They're very similar, so don't get confused. So we have, one of the things from our test is we know we have neutral and line 1. Power is good, and we know that simply because the dryer motor is turning on. It also tells us that the door switch is working, because that wouldn't work in that case. So what we're looking at is the line 2 and the heater assembly, the gas heating assembly itself. Now I want you to notice, even though there are several components within the gas heater assembly, a couple of solenoids, and here's a flame sensor, a temperature activated switch. Remember our symbols over here for switches of various types. Temperature activated switch. So that's the whole burner assembly. But for that to work, it simply needs 120 volts. It has neutral coming in on this black wire, and it has line coming in on this blue wire. So as long as there's 120 volts from black to blue, black being neutral and blue going back to line, as long as we have 120 volts there, the assembly should work. And if we have 120 volts and the burner assembly doesn't work, we have something inside the burner assembly. So let's start our process to see if we have 120 volts across here. The dryer is plugged in. We'll close the door again, and we'll start up the dryer. Here's the burner assembly, and you can see the black wire, and you see actually two blue wires. Well, they are connected together, so you can use either of those two blue wires. And you can tell that's the case on the schematic here. Here's the blue wire coming in, and you see it's connected in one place, two places. It's actually connected in three places, that same blue wire. So any blue wire on that assembly is going to be the same wire. So let's start up the dryer, and we're going to test from blue to black for 120 volts. Remember now, anytime you're working with live electricity, you want to put your gloves on so you don't die. So the door is closed. Let's turn on the dryer and we'll do our test. We're going to set our meter for VAC, volts AC. We're going to put one lead in behind where the black wire is connected, making sure that we make contact. And the second one with this blue wire, which is right next to it. And we're going to have to hold those in. And let's turn the dryer on. Okay, the motor started, so we know it's on. And we hold those in. And our voltage reading is essentially 0. It's bouncing around a little bit, but remember, we're going to ignore the decimal point most of the time, and this is one of those cases. There's no voltage there. So I'm going to turn the dryer off. Since we know now that we don't have 120 volts to the assembly, it's probably not anything wrong with the burner assembly. It's just a matter that power is not getting there. So let's see where it comes from. On the neutral side, going back from the burner, it goes through this black wire. It goes through the centrifugal motor switch. Now, these arrows tell you that when the motor starts up, when it's turning, that switch will close. So once the motor's running, the switch is closed. So let's back up. We go from the burner assembly on black through the motor centrifugal switch over to here, through the closed door switch and to neutral. So there's not much going on that neutral side except wires and this centrifugal switch. The centrifugal switch is a little tricky to test, so let's go to the line side and test that first. So we have the wall plug, and we have line coming in to the timer, and then out of the timer, after passing through one internal timer switch, to red, and that's the high limit switch here. And then the next component, the operating thermostat. And then we have this thermal fuse. Remember, the thermal fuse breaks contact if it reaches over 196 degrees. And this is a safety item to make sure that the venting is working properly. And that would be a fire hazard if it isn't. So this is designed to shut the machine off if it gets too hot. So we are going to use no electricity to test the resistance and the path through the wiring to the burner assembly. Let's unplug the dryer. This is where this alligator clip lead comes in handy. So I'm going to take the pointy lead off of one of my connectors. And for resistance testing, ohm testing, it doesn't matter which lead we use on which end. So I'm going to set the meter for ohms. Remember, it says milliohms. We don't want that. I hit select, and now we just get ohms. When you look at a receptacle or the plug, and we've got the larger hole here and the smaller one there, large is neutral, the small one is line, and then the round one is ground. So on the plug, if you look at it in this configuration, with the ground on the bottom, power is on the right, neutral on the left. It's a good thing to remember. Power, the small one on the right, neutral on the left. That's with the ground hole on the bottom. So if I look at this plug for the dryer, I've got the ground hole on the bottom, line on the right, so this is our neutral connector. Remember also that we talked about the wiring itself, where the ridges that are on the wire tell you that's the neutral wire. Notice on the line side it's smooth. So the side with ribs, sometimes it's just a single rib, the side with ribs is neutral. So that just confirms what we found. That's our neutral line, okay? We are testing L1 or power, so that is the terminal that we're going to use. So I clip onto the L1 terminal to the dryer, and then we're just going to follow our road map. The first stop is through the timer. And if the timer is set to run, which it is, we set it for 50 minutes, this switch should be closed. So coming out of the timer, we have red. So I should have continuity between my plug and the red wire coming out of the timer. Do you hear that? Essentially 0 ohms, and it's making a noise, so I know I have continuity. Once I'm through that timer switch coming out of red, it goes right down to the high limit thermostat. So we can go to that. And you hear we have continuity. 0 ohms essentially. On both sides of that thermostat, that high limit thermostat. So that says that the path from the timer, through that thermostat, and you'll notice this is red with a white stripe. That's called a tracer. So this would be red with a white tracer. And the next stop on our schematic diagram is the operating thermostat, and notice that's red-white. That means red with a white tracer is going to the operating thermostat. So red with the white tracer on the operating thermostat. Now remember, we're still connected to our plug, the line side up here. So we're going all the way through to red with a white tracer on the operating thermostat. And then coming out of the operating thermostat, again, we have continuity. So far, we have from the plug, through the timer, through this thermostat, through the second thermostat. The next wire is red turning to blue, it looks like, to this thermal fuse. So let's take a look at that. If I touch my meter on this lead, you don't hear that familiar sound, do you? Well, let's try this side. We have continuity there. So we have continuity all the way online coming into this, but we don't have continuity going out. That simply means that this thermal fuse is not allowing electricity to pass. I've gone out to my truck and replaced the thermal fuse with a new one. Very simple. You just screw it into that plate and you put the spade connectors back on. I plug the dryer back in, and I make sure the door is closed. And we're going to get a bit of a test. So I turn my meter to volts AC, and then I'll start the dryer up again. The dryer started up. I'm testing from black to blue. And we have 120 volts, and you see the glow of the igniter. That's what you call a successful repair and a happy customer.
Well, thank you, students, for taking the time to watch this video. I hope you learned something from it, and I look forward to seeing you guys again soon. Take it easy. Have fun. If you have any questions about the things that we discussed in the video, you can leave the comments at Pappy's Secrets YouTube or email your teacher. Thanks again.